Hello students, this is lecture number 3 on Laplace transforms. So in the previous lecture we saw the first shifting theorem, second shifting theorem and change of scale theorem of the Laplace transform. So in this lecture also we will study some more theorems over the Laplace transform for solving the examples. Okay, so in that the first property, or you can say the theorem for the Laplace transform, how to find the Laplace transform of the derivative of the term. Okay, suppose we have, if L of f of t is f of s, then if I will take the derivative of this f of t, then if I will take the derivative, that will be d by dt of f of t, what will happen to this RHS? Okay, what will happen to this RHS? Then this will be s into f of s minus f of 0. Okay, if I will take the second derivative of this f of t, like if I will take it like L of second derivative will be d2 by dt square of f of t, then what will be here? This will be like s square f of s minus s f of 0 minus f dash of 0. Okay, this is the derivative of f of t at t equal to 0. Okay, if I will take the third derivative, then this will be L of d3 by dt cube of f of t, and this will be equal to s cube f of s minus s square f of 0, and this will be s f dash of 0 minus so on. This is for 3, so this will be minus f double dash of 0. Okay, on similar base we can calculate the Laplace transform of nth derivative of the function f of t. So this will be dn by dt raised to n f of t, and this will be equal to s to the power n f of s minus s to the power n minus 1 f of 0 minus s to the power n minus 2 f dash of 0 minus s to the power n minus 3 f double dash of 0, and so on. This will be s to the power n minus n, that is s to the power 0 minus f n of 0. This f n of 0 is the nth derivative of f of t at t equal to 0. So what are the things to understand here? If you have the Laplace transform of f of t is equal to f of s, okay, then if you will try and find the derivative of this f of t with respect to t, derivative of f of t with respect to t, then what will be changed in RHS? This f of s, okay, which f of s? This f of s will get multiplied by this s, and you need to write this term as minus f of 0. Okay, and also if you will take the second derivative, again this f of s will get multiplied by the term s square. Now you can see the power of this s is equal to the derivative, the number of derivative you have taken to the LHS over the f of t. Okay, so if you will observe here, d3 by dt cube f of t, you have to differentiate it 3 times. Okay, so what is the power of s? That is also 3, and you need to decrease the power consecutively. Okay, so this will be 3 to 2, 2 to 1, and then 1 to 0. Okay, so that you can define the formula for finding the Laplace transform of nth derivative of the function f of t. Okay, for example, if you want to find the Laplace transform of d phi x by dt raised to 5, okay, then what will be the answer? Now to find the answer, you must know what is the derivative, basic definition. What is the basic definition? If L of f of t is what? If L of f of t is f of s, okay, then you can find the Laplace transform over the nth derivative. Now in this term the dependent variable is x. Okay, so instead of f of t, what we will do? We will take L of xt. Okay, and L of xt, just like f of s, L of f of t is f of s, so L of x of t will be x of s. Okay, so what we have? L of x of t is what? That is what? X of s. Okay, so we can find the fifth derivative of x of t, and it will be given like L of, differentiate 5 times, this will be d5 by dt raised to 5 of x of t. Okay, and what will be to this RHS? This will be like s raised to 5 x of s, instead of f of s there will be x of s minus s to the power 4, and this will be x of x at 0. Okay, this will be s to the power 3, this will be x dash 0. Okay, then this will be minus s square x double dash 0 minus s x triple dash 0 minus fourth derivative of x at t equal to 0. So this will be the fifth derivative of x, the function x of t with respect to t. Okay, so this will be the derivative. Suppose in this example we want to find the Laplace transform of this given differential term. Okay, so what we'll do, we will take Laplace over it. So this will be Laplace of d2y by d2 square minus 3 dy by dt plus 5 y is nothing but function of t. Okay, so applying Laplace over every term by linearity property, so this will be L of d2y by dt square minus 3 dy by dt plus 5 y of t. Okay, so this will be by linearity property, this will be L of d2y by dt square minus 3 L of dy by dt, okay, plus 5 L of y of t. Okay, now in this case we know what are the things we know. L of f of t is what? F of s. Then obviously in this case f of t is function, but now in this case y of t is function, so L of y of t will be y of s. Okay, so for this, okay, for this first term, what will be the Laplace transform? So for the first term, d2y by dt square means to differentiate y with respect to t 2 times and take its Laplace. So its Laplace finally will be equal to s square y of s minus s y of 0 minus y dash of 0. So this is Laplace of this first term, second derivative of y with respect to t, minus 3 times. Okay, now this is the first derivative. By the definition this will be s y of s minus y of 0, okay, plus 5 times Laplace of y of t, just we have solved it here, that is what? Y of s. So this will be equal to into y of s. Okay, so this is your answer, or this will be the Laplace transform of this differential term. Now to find the Laplace transform of this given function and the values for y, y dash and y double dash are given at t equal to 0 to be equal to 1. Now we will solve our example with the basic definition. So we will take Laplace on both sides. This will be Laplace on d3y by dt cube minus Laplace over d2y by d2 square plus 4 times Laplace over dy by dt minus 4 L of y of t. Okay, taking Laplace on both sides, so this will be Laplace over t. Okay, now take Laplace separately. Okay, firstly we will see for the first term, and it is of degree 3, so this will start from s cube and the function is y, so this will be y of s minus s square y at 0 minus s y dash of 0 minus y double dash of 0. Okay, now about this second term. Okay, so this will be minus in bracket. Now it is of the second degree, second derivative, so this will be s square y of s minus s y of 0 minus y dash of 0. Okay, now about the third term, this one. Okay, so this will be plus 4 times first derivative, so this will be s y of s minus y of 0, okay, minus 4. Okay, now about this term, okay, L of y of t, so this will be minus 4 y of s. Okay, and to the RHS, the Laplace of t. Okay, this is algebraic function, so this Laplace will be the value for n is equal to 1, so it will be 1 factorial is 1 upon s raised to 2, so this will be equal to 1 by s square. Now what we are given, we have given these values, okay, y of 0, y dash of 0, y double dash 0 is equal to 1. Okay, so what we have what, y of 0, y dash 0, y double dash 0 is equal to 1. So put the values, we can see y of 0, y dash of 0, y double dash of 0, also here also y of 0, y dash 0, here also y of 0. Okay, so put every value equal to 1 basically. Okay, so this will become, okay, s square first term as it is, okay, minus s square, okay, and this term is equal to 1, okay, this is into 1 minus s, again this y dash of 0 is 1, okay, minus this is also 1 minus, okay, this will be s square y of s minus, again this value y of 0 is equal to 1, so this will be into 1 minus this y dash of 0 is equal to 1, so this will be into 1, okay, plus 4 into s y of s minus y of 0 is again 1 minus 4 y of s, okay, is equal to 1 by s square. Okay, now collect the terms of y of s. Okay, if you will observe here, this is the term of y of s, this is also the term of y of s, this is also the term of y of s, and this one is also the term of y of s. Okay, so if you will take the terms, if you will take y of s out from every term, okay, so what will remain here, okay, what will remain here, s square, okay, and here minus sign is outside the bracket, so this will be minus s square, okay, and for this term what remains here, plus 4s, is it, then what remains here, minus 4. Okay, now collect remaining terms. What remains here, these are the terms, remaining term. Okay, the terms are like minus s square, minus s, minus 1, and those terms minus sign is outside, so this will be minus minus plus s, this will minus minus plus 1, this will be 4 into this minus 1, that will be minus 4, okay, and is equal to 1 by s. Okay, now just try and solve this. This is equal to 1 by s square. Okay, so this will be y of s in bracket s square and s square will get cancelled. Okay, so what remains, only 4s remains. Okay, this will get cancelled, so what remains, 4s. Okay, this will be into 4s minus 4 bracket, again this minus s plus s cancel, minus 1 plus 1 cancels. Okay, so again what remains, minus s square minus 4 is equal to 1 by s square. Okay, so finally we can write this term as it is and take this term to the RHS. So what remains, y of s in bracket 4s minus 4. Okay, these terms are negative, so it will be positive to the RHS, so this will be 1 upon s square plus 4. Okay, so finally we can find the value for y of s, that will be 1 by s square plus 4 in the denominator, this will be 4s minus 4. So this is your final answer, this is the final Laplace transform y of s. Okay, we'll see the next example. Try some examples over the finding the Laplace transform of the derivatives. Now the next term is how to find the Laplace transform of the integral term. Okay, so again, if L of f of t is equal to f of s, okay, if L of f of t is what, f of s, then if you will take integral over this f of t, means what, this is your function f of t. Okay, and if you will take integration over this f of t under the limit 0 to t, okay, dt, okay, then what will be changed in RHS? Okay, in the RHS this f of s will get just divided by f of s. Okay, and that will be the answer when you will integrate f of t with respect to t under the limit 0 to t. Okay, and that is what the Laplace transform will be. Okay, for example, if I want to find the Laplace transform of this given differential, okay, see how to get the Laplace transform of this. So what we'll do, we'll take Laplace over the given differential, so this will be d2y by Laplace over d2y by dt square plus 3 dy by dt plus 4 y of t plus 2 0 to t y of t dt. Okay, now by linearity property, this will be L d2y by dt square plus 3 Laplace of dy by dt plus 4 Laplace of y of t, okay, plus 2 Laplace of integration 0 to t y of t dt. Okay, this is important. Now in the previous case only we saw how to get the Laplace of this, okay, and it is the second differential, so its Laplace will be s square f of s minus s f of 0 minus f dash of 0, okay, plus 3, this is the first derivative with respect to t, okay, so this will be 3 into s f of s minus f of 0 plus this is L of y of t, that is y of s, this will be 4 into y of s, okay, and the function is y, so we should not take this as f of s, we should take every term in terms of y only, okay. So Laplace of this in terms of y will be, okay, this will be s square y of s minus s y of 0 minus y dash of 0, okay, plus about this term 3 times first derivative means s y of s minus y of 0, okay, plus 4 and Laplace of y of t is nothing but y of s plus 2. Now this is, see, what is this? This is the integration over this function y of t, okay, and what we have seen in the definition, if you will take the integration over here, 0 to t, what will be changed here? This f of s will get divided by this s, that's it, okay. That is what we have to do here. Only this Laplace of this will be what? Y of s, and you just need to divide it by s, and that will be your final Laplace transform of the given differential, okay. Now in the next term, in the next property, we will see what will happen or what to do when the function f of t is multiplied by the power of t, okay. What it means, so suppose we have, if L of f of t is equal to, suppose f of s, okay, what this means, it means what? Laplace transform of f of t is f of s, okay, Laplace transform of f of t is f of s, and then if you will multiply this f of t by some t, okay, if you will multiply this f of t by some t, okay, t to the power 1, then what will happen to the RHS? What will happen to the RHS? To this f of s. What is this f of s? This f of s is L of f of t, okay. So to this f of s, you just need to take its derivative with respect to s, okay. Hope it is clear. If I will multiply 2 times, okay, if I will multiply 2 times with t, so this will be t square for this function f of t, then what will happen? This will be what? Again, see what is happening here in the first case. This is L of t into f of t. What you are doing? You are taking the derivative of what? Derivative of what? F of s. And what is this f of s? This f of s is nothing but Laplace of this f of t, okay. So same thing will be happen here, okay. So again you will have to take the derivative of what? Derivative of what? Laplace of this function. I can write this t square as t into t. So Laplace of t into f of t is what? This thing, okay. So this will be minus d by ds of f of s, okay. So this will be d2 by ds square f of s, okay, and so on. If you will multiply this f of t by t to the power n f of t, okay, then see this will be equal to minus 1 raised to n dn by ds raised to n f of s, okay. And this is our definition. What will happen when the function f of t is multiplied by the power of t, okay. So what will be the change in RHS? You will have to take that much derivative with respect to s and multiply that term with respect to by minus 1 raised to n, okay, where n is the power of t, okay. For example, I want to find the Laplace transform of t into sine 2t, Okay, now we know by the definition of multiplication by t. Okay, what is the definition? If L of f of t is what? F of s. Okay, then if I will multiply this f of t by t, what will happen? You will have to take the derivative with respect to s of f of s. But what is this f of s? This f of s is nothing but L of f of t. Okay, so firstly you will have to identify what is f of t. So what is f of t? F of t in this case is what? Sin 2t. Okay, so taking L on both sides, this will be L of f of t. So this will be L of this sin 2t. Right? We need this f of s, and f of s is nothing but L of f of t, and L of sin 2t is nothing but 2 upon s square plus 4. Okay, so once you will get this f of s, okay, now you can write or you can insert what? T here. Okay, once you will get the value for f of s, you just need to insert t near to this sin 2t. Okay, so see what will happen. Multiply this sin 2t by t, so this will be t into sin 2t. Okay, what will be changed here? What will be changed? Minus d by ds of f of s. Okay, so minus d by ds of 2 upon s square plus 4, because f of s is 2 by s square plus 4. 2 is constant, so this will be minus 2 d by ds of 1 upon s square plus 4. Okay, and the derivative of this term will be minus 2, that will be minus 1 upon s square plus 4 square into derivative of s square plus 4 is 2s. Okay, so finally this will be minus plus 4s upon s square plus 4 to the power 2. Okay, so this will be our final answer for finding the Laplace transform of t into sin 2t. Okay, you just need to identify the smallest term whose Laplace is known to us, and also the definition. Okay, definition is what we are doing over that f of t. Okay, if you are multiplying it by t, then use the definition of that. If you are taking derivative, then use definition of that. If you are dividing by t, then take the definition of that. Okay, so it's very simple. If you will observe in this case also, t into e raised to minus 3t. So to find the Laplace transform of this function, so identify what is the minimum thing whose Laplace is known to us. Okay, so what is the minimum thing? E raised to minus 3t, whose Laplace is known to us, that is what? 1 upon s plus 3. Then what you will do, you just need to insert this t here. Okay, and use the definition. So t into e raised to minus 3t. Okay, so when you are multiplying this function by t, there will be some change in RHS, and that change is what? Minus d by ds of 1 upon s plus 3. Okay, so this will be minus d by ds of 1 by s plus 3. Okay, so this is what? Minus 1 upon s plus 3 square. Okay, this will be minus. So finally our answer will be 1 upon s plus 3 square. Okay, hope it is clear. Okay, suppose I will take t into, I will take one more example over here only. Okay, example, if I will take this as t into cos 2t, suppose. Okay, so what I told you, take the minimum Laplace whose Laplace transform is known to you. Okay, what is the example? Example is, suppose we want to find the Laplace of t into cos 2t. Okay, so firstly find out whose Laplace, minimum term whose Laplace is known to us directly. Okay, whose Laplace is known to us? We know the Laplace of cos 2t directly. Okay, so you know Laplace of cos 2t. Okay, and Laplace of cos 2t is nothing but s upon s square plus 4. Okay, and this term is nothing but f of s, right? So now what you will do, you will just insert this t here and use the definition. So L of t into cos 2t. So there will be some change in RHS. What is that change? Minus d by ds of f of s. But what is f of s? F of s is s upon s square plus 4. So taking derivative by u by v rule. So what says u by v rule? Take square of the denominator, s square plus 4 whose square. Okay, then take this term here, s square plus 4. Take derivative of numerator, derivative of s with respect to s will be 1, minus the numerator as it is, and then take derivative of denominator, and denominator is s square plus 4 and its derivative is 2s. Okay, just simplify this will be s square plus 4 minus 2s square upon, this will be s square plus 4 square. Okay, then again this will be s square and this will be minus 2s square. So what remains here? Minus s square plus 4 upon s square plus 4 square, which is equal to, apply minus sign, so this will be s square minus 4 upon s square plus 4 whole square. Okay, so this will be the answer. Okay, suppose you want to find the Laplace transform of sine of 4t, and this sine of 4t is multiplied 2 times by t. Okay, so instead of solving directly for 2 times, we will solve one by one. Okay, this t square sine 4t, I can write it as t into sine 4t. Okay, and firstly I will find the Laplace transform of t into sine 4t. Okay, so to find the Laplace transform of t into sine 4t, you need to identify what is the minimum term whose Laplace transform is known to us directly. So we know the Laplace transform of sine 4t directly. Is it? We know the Laplace transform of sine 4t directly using the standard Laplace transform, that is what, 4 upon s square, square of 4 is 16. Okay, so we got the Laplace transform of 4t. Now insert this t here. Okay, so what will happen? This will be like L of t into sine 4t. What will be changed to the RHS? You need to take the derivative of it with respect to s of what? F of s, and f of s is 4 upon s square plus 16. So take derivative, minus 4 is constant, that is d by ds of 1 upon s square plus 16. So this will be minus 4, and derivative of this will be minus 2s upon s square plus 16 square. Okay, so what we have got? We got this as 8s upon s square plus 16 square. Okay, and this is what? This is the Laplace of t into sine 4t. Okay, but we are not done yet now. Okay, we want to find the Laplace transform of t square. So again you need to multiply it by t. Okay, so what will happen? Again multiply by t to what? This term. So L of t into what? T into, to multiply this t into sine 4t. What we are doing? We are multiplying this t sine 4t by what? T. So what will be change in RHS? Whatever we have here, you need to take its derivative, minus d by ds of 8s upon s square plus 16 square. Okay, so take derivative with respect to s, and that's it. That will be your answer. Okay, so this will be minus, you need to apply the division rule for finding the derivative. Okay, so this will be s square plus 16 square, that will be raised to 4. What will remain here? This will be s square plus 16 square into derivative of 8s is 8 minus derivative of this term with respect to s, that is what, 2 into s square plus 16 into again derivative of s square plus 16 is 2s. Okay, and this term 8s as it is, so this is into 8s. Okay, so try and simplify this term. Okay, so when you will simplify it, when you will try and simplify this term, okay, now see what will happen. Okay, this is what? This is the Laplace of t square sine 4t. Okay, minus of this, so minus of 8 into, say this is s square plus 16 whole square. Okay, so this will be s to the power 4 plus 2 into s square plus 16 square. Okay, that is what, 256. Okay, into this 8 minus, this will be 2, this is 2, this 2 and this 8. Okay, so that will be 32 s into s square plus 16. Okay, upon, what is that? This is s square plus 4 to the power 4. Okay, so this will be minus, this will be 8s to the power 4 okay, plus 16s square, okay, so this will be 256 into 8 minus this will be 32s to the power 3 minus 32 into 16 into s, okay, upon this will be s to the power 2 plus 4 to the power 4, and this will be your final Laplace transform for t square into sine 4t. Okay, if you will take this one more example, okay, again this f of t, this is your f of t e raised to 2t, which is multiplied 2 times by t. Okay, so find out which is the minimum thing whose Laplace transform is known to us. Okay, so e raised to 2t is the minimum thing whose Laplace transform is known to us. Okay, and we know the Laplace transform of e raised to at, Laplace transform of e raised to at is what? 1 upon s minus a. Okay, so this will be like 1 upon s minus 2. Okay, now insert 1t. Okay, because I can write this t square as t into e raised to 2t. So what we are doing, we are just trying to find Laplace of this t into e raised to 2t. So insert this t first. This will be t into e raised to 2t. Means what will be change in RHS? In RHS, whatever f of s we have, that will get, we need to take its derivative with respect to s. Okay, so this will be 1 upon s minus 2's derivative with respect to s. This will be minus 1 upon s minus 2 square. So this will be 1 upon s minus 2 square. So what is this? This is Laplace of t into e raised to 2t. Okay, now again what you are doing? Again multiply by t, because we need what? T square into e raised to 2t. So this thing is multiplied by t again. Okay, so multiply by t. So what will happen? This will be t into t e raised to 2t. Okay, so what will be change here? You need to take its derivative with respect to s. Okay, so derivative of this s minus 2 square with respect to s. So this will be minus 1 upon, the derivative of this will be minus 2 upon s minus 2 to the power 3. So this is equal to 2 upon s minus 2 to the power 3. Okay, you can find its Laplace transform using first shifting theorem also. Okay, also you will get the same answer, that is 2 upon s minus 2 to the power 3. Okay, so hopefully you are understanding. Suppose you want to find the Laplace transform of this function. Okay, so find out what is the minimum thing whose Laplace transform is known to you. So we know the Laplace transform of sine 2t. What is the Laplace transform of sine 2t? Sine 2t's Laplace transform is 2 upon s square plus 4. Okay, now insert terms one by one. So firstly we will insert e raised to 3t, and you will use the rule, whatever rule you need to use, then insert this t. Okay, so one by one every term we will insert. So firstly we will insert this e raised to 2t. Okay, so L of e raised to 3t into sine 2t. Okay, now you know what is this? This is nothing but the first shifting theorem. So what we do in first shifting theorem, whatever f of s we have, in this f of s we replace this s by s minus 3, because the sign of 3 is minus here. That is why we are, my sign of 3 is plus here. That is why we are taking this as minus. Okay, so what is f of s? F of s is what? L of f of t, means L of sine 2t. L of sine 2t, and L of sine 2t is nothing but 2 upon s square plus 4. So in this replace this s by s minus 3. So what you will get? This as 2 upon s minus 3 square plus 4. Okay, so that will be Laplace transform of e raised to 3t into sine 2t. Now insert this t here. Okay, so this will be L of t into what? E raised to 3t into sine 2t. Okay, what will be here? This will be minus d by ds of f of s. Now what is this f of s? This f of s is nothing but Laplace of this term, and Laplace of this term is known to us, that is 2 upon s minus 3 square plus 4. Okay, so what will happen? This will be minus d by ds of f of s, that is 2 upon s minus 3 square plus 4. Now take the derivative with respect to s. So this will be minus the derivative of this term with respect to s will be, this minus 2 is constant, so it will be out, and the derivative of this term with respect to s will be minus 2 into s minus 3 upon this will be s minus 3 square plus 4 whole square, and that will be your final answer. Okay, now we will see what will happen when the function f of t is divided by power of t. Okay, suppose if L of f of t is suppose f of s, L of f of t is what? F of s. Then what to do? Then if you will divide this f of t by the power of t, if you will divide this f of t by the power of t, suppose I will divide it by t raised to 1, then see what will happen. Okay, then L of, if you will divide this f of t by t raised to 1, then there will be some change in this f of s. And what will be this change? You need to take the integration of this f of s under the limit s to infinity. Okay, and integrate it with respect to s and take the limit s to infinity, provided this limit t tends to 0, f of t upon t exists. Okay, so this is our basic definition for Laplace transform when f of t is divided by power of t. If I will divide one more t, so this will be L of f of t upon t square. Then you need to take again one integration, s to infinity f of s ds square. Okay, means what? This is the double integration of f of s with respect to s. Similarly, if I will divide this f of t by the power of t, okay, and take its Laplace, okay, so what will be here? This will be like s to infinity, so on up to s to infinity. This will be n times, okay, this integration will be n times, okay, of this f of s ds raised to n. Okay, and this is how we will solve the examples. Okay, for example, you need to find the Laplace of this e raised to minus at upon t. Now you can clearly see, so one function is divided, something is divided by t. Okay, what is that something? Okay, firstly you need to understand what is the definition. What is the definition? If L of f of t is what? F of s. If L of f of t is f of s, then if you will divide this f of t by t, what will be change in RHS? S to infinity of f of s ds. And what is this f of s? This f of s is nothing but this f of s, and this f of s is what? L of f of t. So you need to identify what is f of t. So find out what is f of t and take its Laplace. So L of e raised to minus at is equal to what? 1 upon s plus a. Okay, so this is nothing but our f of s. Okay, so when you will divide this e raised to minus at by t, so this will be L of e raised to minus at by t. What will be changed to this f of s? You need to take its integration with respect to s of this f of s with respect to s under the limit s to infinity. So this will be s to infinity, but what is f of s? F of s is nothing but 1 by s plus a into ds. Okay, and take the integration. The integration of this will be log of s plus a only. Okay, but this is under the limit s to infinity. Okay, so this will be like log of, now this is nothing but limit s tends to infinity, log of s plus a minus, put lower limit, log of s plus a. Okay, this term will tend to infinity and the answer will tend to infinity. Okay, we'll see the next example, see what happens in the next example. Okay, we'll see this example, that is you need to find the Laplace of this term. So firstly identify what is f of t. Okay, so what is f of t in this case? F of t is e raised to minus 2t minus e raised to minus 3t. Okay, so find out its Laplace. Its Laplace will be bilinearity, Laplace of e raised to minus 2t minus Laplace of e raised to minus 3t. Okay, and Laplace of e raised to minus 2t is nothing but 1 upon s plus 2. Laplace of e raised to minus 3t is nothing but 1 upon s plus 3. Okay, so this will be our f of s. This is the value for f of s. Okay, now divide this whole thing by power of t. Okay, so see what will happen. This will be L of this e raised to minus 2t minus 3t is divided by t. t to the power 1, what will be changed to this f of s? You need to take the integration of this f of s with respect to s under the limit s to infinity. Okay, so put the value for f of s. So f of s is nothing but 1 upon s plus 2 minus 1 upon s plus 3, okay, ds. Okay, and integration of this will be log of s plus 2 minus log of s plus 3, okay, under the limit s to infinity. Okay, so by using logarithmic rule, this will be equal to log of s plus 2 upon log of s plus 3 under the limit s to infinity. Okay, now we'll calculate this limit. First put upper limit. Upper limit was infinity, means what? Limit s tends to infinity of log of s plus 2 upon s plus 3 minus lower limit log of, put s. What is lower limit? S. So put s is equal to s. So what we will get? The term will remain as it is, s plus 2 upon s plus 3. Okay, now solving this will be limit, okay, s tends to infinity log of, okay, take s common from this, what remains here? 1 plus 2 by s, and also take s common from this, so this will be 1 plus 3 by s, okay, minus log of s plus 2 upon s plus 3. Now see what happens. This s and s will get cancelled. Okay, so and this term will tend to 0 as s tends to infinity. Now what are the terms there? You can just observe here. What is the term there? Limit s tends to infinity 2 by s, and as s tends to infinity, this term tends to 0. So this term will be 0. This term will be 0. So log 1 will be 0. So first term will become 0 minus log of s plus 2 upon s plus 3. Okay, and this is your final answer for the given function when divided by power of t. Now if you observe this example, okay, again same type of example. So you just need to identify what is the minimum thing whose Laplace transform is known to you, and then apply the corresponding definition. So we know the Laplace transform of cos at minus cos bt. Okay, so by linearity this will be Laplace of cos at minus Laplace of cos bt. Okay, Laplace of cos at is nothing but s upon s square plus a square, and Laplace of cos bt is nothing but s upon s square plus b square, and this is nothing but our f of s. Okay, now what you will do? You will divide this f of t. What is f of t? F of t is cos at minus cos bt. So divided by t. So this will be L of cos at minus cos bt, and divide it by t. Okay, so what will be changed to RHS? You need to take the integration with respect to s of f of s. But what is f of s? F of s is s upon s square plus a square minus s upon s square plus b square ds. Okay, now take integration of this. This will be integration s to infinity s upon, okay, I need to adjust. Okay, we'll write it separately. S upon s square plus a square ds minus integration s to infinity s upon s square plus b square ds. Okay, now adjust some term to find the integration. So what will be adjustment? Divide and multiply by 2, so that we can find its integration directly using our one of the formula. Okay, and that formula, which formula we will use? S to infinity 2s upon s square plus b square ds. Now which formula we will use here? This formula, integration f dash of x upon f of x dx. Okay, means what? If function is there and in numerator its derivative, then what will be its answer? Log of f of x. Okay, now you can see s square plus a square is a function and 2a is its derivative. That's why we have adjusted this 2. Okay, so its answer will be 1 by 2 log of s square plus a square. Now 1 by 2 is common in both terms, so I can take it out. So its answer will be log of s square plus a square. Okay, under the limit s to infinity. Now using the logarithmic rule, this will be 1 by 2. Okay, this will be log of s square plus a square upon s square plus b square. Okay, this is b square under the limit s to infinity. Okay, we'll take this term to the next page. And see what will happen. We need to find its integration now. Okay, now we need to put the limits. This 1 by 2 is constant, which is out. Now put the upper limit minus lower limit. Upper limit is infinity, so we cannot put it directly. So this will be, I can write this as limit as s tends to infinity. So log of s square plus a square upon s square plus b square minus, put s is equal to lower limit, and lower limit is s, so the term will remain as it is, s square plus a square, s square plus b square. Okay, now solving this will be 1 by 2. Okay, so I can write this as limit s tends to infinity. Okay, log of, okay, now see this, now take this s square out, so what remains in bracket, 1 plus a square by s square, also in denominator s square will be out, b square by s square, okay, minus this term as it is, log of s square plus a square upon s square plus b square. Okay, now again if you observe here, this term will get cancelled, and as s tends to infinity, this term will tend to 0, means this term will be 0 and this term will be 0. So what remains, log 1, and log 1 is 0. Okay, so this will be 0 minus, what is the term here, what will be the final answer? This will be like 1 by 2 in bracket, this term will be 0 minus log of s square plus a square upon s square plus b square. Okay, and because of this minus sign, okay, the terms of the logs will get reversed. This will be in numerator s square plus b square, and this will be in denominator s square plus b square. And this is how we solve the examples over when the function f of t is divided by t. We saw it, what will happen when we take the derivative, when we take the integration, when we multiply by t, and when we divide it by t. Thank you.